Hey, everybody. I want to walk through a solution to question 4 from today's practice. So you see the stumper on your page. What is the smallest perfect square that is greater than 20,000 and divisible by 392? Okay. Well, the first thing I want to address in this is the problem says that it has to be a perfect square. So what does a perfect square mean? Well, it means that you have 2 of the same factor. So if I had 4, I know that that's a 2 and a 2. If I have, 64, then that's an 8 and an 8. But that would also be like a 4 and a 2 and a 4 and a 2. And you notice those 2 2s make another 4. And so what you always have are factors that are perfect squares, or 2 of the same factor. Now, that quick little walkthrough is the theory we're going to use to get some things started. We may end up going and trying to go, well, okay, like what's 20,000 right now divided by 392? And if you went to make that calculation, to try to end up figuring out like, well, what's that going to take to get above, because it does say greater than 20,000, I'll be honest with you, I don't even care about that right now. Like I really don't, because it doesn't satisfy the perfect square component. So what I'm going to do is I'm going to first factor 392 and see what makes up 392. So if I took 392 and I started to break it down, let's say we see that it's an even number, so we know that we can divide it by 2. So 392 divided by 2 gives me a 196. Okay, let's say that we can recognize that 196 is 14 by 14. It's a perfect square. Like, let's say we can. Outstanding. That helps us out so much. I'm going to act as if we didn't know that. I don't expect you guys to have 196 memorized as a perfect square. So let's say that we just keep going. Maybe, though, you're inclined, since you're looking for perfect squares, to not bail out and say another 2, but maybe instead you say, like, hey, does 4 go in there? And so when you take 196 and you divide it by 4, you get 49. Okay, I'm going to stop there because I think that that's a likely factor tree for us. Then what that means is that 392, we just found out, is a 2 times a 4 times a 49. Or if we needed it written that explicitly, it's a 2 times a 2 squared times a 7 squared. Okay, I'm going to get rid of my factor tree. If we recognize the blue and we need to find a number that is divisible by 392, then the only numbers that are divisible by 392 are numbers that have a 2, another 2 2s, and 2 7s as its factors. If it's divisible by 392, then it must be divisible by all of those factors. That's what we mean when we say divisible, divides evenly. Okay, our problem is 392 is not a perfect square because we can see that first 2. It's not a perfect square. So how do I get the ball rolling on this? And I'm just going to put that 2 back in there. Well, what it means is if a perfect square always has at least 2 of every factor, or exactly 2 of every factor to some extent, then this blue does not give me a perfect square because of the leading 2. So what I need to do is I need to put another 2 in there. That's what I got to do. Now, I don't want to write it on that line because I don't want to make it look like 392 is equal to that. So what I need to do is take that blue stuff and now start to figure out what I need. So I need to put another 2 in there. And that's why you now see that 2 squared. Okay, I'm going to calculate that number. You'll notice that is just 392 with an extra 2, so maybe that makes it a little easier. But I'm going to calculate that number. When I do that, that gives me 784. 784 is a perfect square. You can see it because there's 2 of every factor. Now, as I start to look and consider, okay, I need to find a number that is a perfect square greater than 20,000. I'm going to need to find a number that has 784 in it. Whether you want to keep those values there, I'm just going to write them in a different color. My 2 squared times my 2 squared times my 7 squared. But I need to make sure that 784 is divisible, or the number I find is divisible by 784. So what I might do now then is maybe I'm going to take 20,000 and I'm going to divide it by 784. And I want to start to see, like, well, how many times does 20,000 divide by 784? And if I made a calculation on that, I'm just going to write down that that would be approximately like 25.5. Now, I would have loved it if it was like 24.9, let's say. And here's where we're going to get to our theory. If it was 24.9 and not quite 25, I love the fact that the answer was like close to 25, because 25 is a perfect square. That if I now said I'm going to take 784 and look over to the right, and I just multiply that by 25, then because 25 was bigger than what I needed, I would get a value greater than 20,000, and I would have ensured that it was a perfect square because I picked 25, and 25 is a perfect square. You can see that up here. All perfect squares. But when I made the calculation of 20,000 divided by 784, I got 25 point something. I'm just going to put that 25.5 back in there. So if I just multiplied by 25, and just to have the discussion so you can see, that gives me 19,600. That is a perfect square. Like the square root of 19,600 is exactly 140. But my problem is 19,600 is not greater than 20,000. So when I go through and I see that 25.5 in yellow, what that means is I have to make sure that I'm adding in perfect square factors that are going to get me something more than 25. So let me slow walk this a little bit. If I multiplied that by 4, clearly I'm not going to get big enough. If I multiplied that by 9, another perfect square, clearly that's not going to get me big enough. But if I multiply that by 25, because I'm trying to put in a 5 squared as I build up, that's not going to be big enough. Maybe then I go, well, then why don't I just put in like another 2 squared, like a 4, something really small. What you might notice then is that's a 25 times 4. That's you multiplying by 100. That's going to give you a number significantly bigger than 20,000. 78,400. Okay, there's got to be a perfect square that's divisible by 392, but closer to the 20,000. So as I'm walking my way through, if I multiply that by 6 squared, then that's going to get me to something that's still a perfect square, but closer to the 20,000. So why am I multiplying by 6 squared? because 6 squared is going to be the smallest perfect square bigger than 25. Okay. If I now make that calculation and I get rid of those and I see that I'm going to multiply that by another 36, then if I take 784 and I multiply it by 36, I'm just going to shrink this down, slide it up, then that is going to give me 28,224. And there is the smallest perfect square greater than 20,000, but also divisible by 392. Do a quick check. Take the square root of 28,224, and you're going to notice that if you take the root of that, you get exactly 168. And if you took 28,224 and you divide it by 392, you should not be shocked that it's divisible, because you can see all of the factors are in there. Then we get exactly 72. Okay, that one's a little bit of a doozy, but it gives you some practice just working your way through factors of numbers. Okay, I'm hoping that one helps out. Best of luck with your other practice.